My name is Sohan Maheshwar. I'm based in Amsterdam. And I've been in the industry for 15 plus years, including spent time at Amazon and some startups. So today I'm going to be talking about preventing AI agents from accessing unauthorized data. And largely today's talk is focused on this problem of authorization that we face today. Now, the chunk of today's talk will be about authorization, and a little bit will be about AI agents, RAG pipelines, LLMs, and more. But I have a question before I start. I must warn you, if you know the answer to this, you might reveal your age, right? So before you shout out the answer, think about that. But does anyone remember this website from the early 2010s? It was yes? Want to shout it out? Sorry? Yeah, Google+, that's correct. So I'm not the only old person in the room. So for the younger people in the crowd, you might not know of this social network that Google came up with. And it was called Google+, or also Google Circles, where the idea was it had to be different from Facebook, where everyone could view everything. But here, essentially, you could put people in circles, say university friends, family, school friends, whatever, and share certain things with certain circles. And the idea was you could control who you're sharing what with. And the story goes that Google actually worked on how their internal authorization worked because of Google Circles. And we sort of know that because if you've ever done something like this, which is when you're sending an email in Gmail and you add a Google Docs link, there's a pop-up that asks you if you have permissions for that intended receiver to actually see the document. Has anyone seen this? Yeah? Excellent. So if you think about this, this is actually magic because Gmail and Google Docs are two separate apps. But there is an authorization check, a permission check between the two. And this is because Google centralized their authorization across all of their applications. And their internal authorization system is called Zanzibar, and that's what I'll talk about. Let me give you a quick primer or a quick history lesson on the world of authorization. Now, authorization is different from authentication. Authentication is identity, so who you are. You might have used LDAP or Okta or whatever. Authorization comes after that. Once we know who you are, what can you access? What permissions you have? And we've seen different ways of doing this. Very, very early on, there were lists, right? So one large list of people who can access document 123, right? Not scalable. And things changed a little for something called role-based access control, or RBAC. You might have this in your companies where you are tagged to software engineer, so you can check in code. That is your role. Someone is tagged to sales, so they can access sales reports. That is their role. Again, not the most scalable approach. An improvement on that was something called attribute-based access control, where everyone had an attribute. So if I was accessing something, my name, email ID, location, office, all of that would be an attribute. And at the point of decision, all these attributes would be checked, and a decision would be made. Now, this also can get complicated at scale. And Google realized that they needed something for their planet-level scale. So they popularized this thing called RBAC, or relationship-based access control. And they have detailed their entire authorization system in a paper called Google Zanzibar. It's confusingly titled the same thing. And this paper was released in 2019, so it's fairly new. Now, I would actually get you all to read the paper when you're free. It's written in plain English, so it's simple to follow. And in the paper, they accurately describe how their internal authorization system works. Now, it's global, it's consistent, which is the first word of the title. And those of you all here who have worked in distributed systems know that consistency is a hard problem to solve. In 2019, they said that they were doing more than 10 million client queries per second, which is a very impressive number. And I'm sure that number has increased by now. And it spoke about this model called relationship-based access control, or RBAC. So what is RBAC? Instead of having roles or attributes, everything is described in the form of a relationship. So for instance, you have a document called Steal the Moon. The document is in a folder, so the relationship is it exists in a folder. And you have people, and people can be a viewer of the folder, and hence viewer of the document. People can be an editor of the folder, and hence can edit the document. So everything is expressed in terms of relation. What is everything here? Well, in the Zanzibar paper, they say one thing is a user ID. So that's constant, a user. And the other thing can be any object. So in a Google Doc style example, it could be a folder or a file, but it could also be something like a Google group, or it could be a video or something on Google Maps, or a photo even. And essentially, there's a relationship between the user and the thing. So a member of a group is a relationship, or an uploader of a video is another relationship. So you have these users and objects, and you have these relationships. How do you define these? So the Zanzibar paper does this in the form of something called a relation tuple, which basically is a way to express this relationship. So in this case, I want you to start with the hashtag that's here. Start what's on the right of the hashtag. So user number 3 is an owner of document 123. And if this is confusing to you, contact Google, not me. And this gave them a lot of flexibility, because you can also express objects that can relate to other objects, or objects that can relate to other objects' relations. So in this case, group security is a member of group engineering. Now imagine at work you have a reorganization, and say the security group actually moves to sales. If you had a role-based access control, that's just another whole lot of effort to change it around. But here, you just change this tuple and say, group security is now a member of group sales, and that's it. Your access and your permissions are already set. So this gave them that flexibility. But what are we really doing here? Right? The idea is to take all of this data and represent it in a directed acyclic graph. If you've studied computer science engineering, you know that traversing graphs is an efficient way of getting information. So again, going back to our classic Google Docs example, say you have a document, and you have people who are readers of the documents, Fred and Kim, and you have writers of the document who are Jill. You might notice a dotted line here, which implies everyone who's a writer is also a reader. And this is very flexible, because suddenly there's a new requirement saying, hey, you know what? Add an organization to this as well. Super easy. All you have to do is add a new relation saying, this document has an organization named Acme. Acme has something called admin, and anyone who's admin can be a writer. And we already know anyone who's a writer is a reader. So this way, it gave them enough flexibility to express these different relations and permissions in a directed acyclic graph. So how do you check if someone has permissions or not? Well, it's straightforward. Let's check if Jill can read some document. All you have to do is see if there is a path between the document and the person. So in this case, there is a acyclic way, or there's a unidirectional way of going from some document to reader to writer to Jill, and hence, Jill can read this document. If you say, can Fred write to this document, there is no path in one way to go from Fred to writer to document, and hence Fred does not have permissions to write to this document. So if you've ever used a Google Doc link before, or if someone's given you permissions, this is actually what's happening behind the scenes. Now, the question that I get asked when I'm talking about this is, surely this does not scale. Right? How can this scale to like planet level 10 million queries? Well, a lot of it comes down to the architecture. It was built for global scale, Google scale. And that is an entire talk in itself. But if I have to give you a summary, there are two things that happens. One is everything is broken down into sub-problems. So in this case, this is a union of a problem of, is Jill a reader? Is Jill a writer? Is Jill an admin? Right? And every time it traverses the graph, it actually stores that and caches it very aggressively. So the check would go reader, Fred, Kim, and then those results are stored in the cache. And then it would go writer, Jill, yes. But the next time someone asks if Fred can read the document, that is already cached in the system. So that way, there's aggressive breaking down into subproblems and aggressive caching to do things like low latency, high availability, and scale. Again, all of this is described in great detail in the paper. So this came out in 2019, and it sort of sent shockwaves in the industry, especially people in the IAM space, identity and access management, because they were like, whoa, this is a completely new approach. In fact, companies like Airbnb and Carter built teams to restructure their authorization around this, and they still do it that way. At the same time, people started building open source versions of this, and the 4 popular ones right now that are open source implementations of this are the ones you see here. There's SpiceDB, Ori, OpenFGA, and Permify. I will show you a demo of SpiceDB today because I work on SpiceDB. Just to give you some more information about SpiceDB, it's again an open source implementation of Zanzibar, completely community engaged process. The coding of SpiceDB started around 2020, but now it has contributions from Red Hat, Reddit, GitHub, and more. But of course, the one metric that matters to us as developers is GitHub stars. So we have about 5,700 GitHub stars right now. Could always use more. What is SpiceDB, though? As the name suggests, it is a database, but it's not a general purpose database. You can't use it as an RDBMS and store documents and data. Instead, it is a highly parallel graph database only meant for authorization queries. So for asking questions like, does this user have permission, you would use something like SpiceDB. As a developer, so for you and me, it's basically just an API. There are APIs written in both gRPC and HTTP, and SpiceDB in itself is written in Go. And the APIs do 3 things, right? They do read and write schema. What is a schema? Well, Google Zanzibar describes schema as a way to define the objects found and the relationships in between them. And you can take any use case you have. It doesn't have to be like just documents or photos. It could be banking or something in your university. And you can model that using schema. So again, to give you the standard example of Google Docs, you have a user, you have a document, and you have the relation between the user and the document. A user can be a writer or a reader. And each of these relations have different permissions. A writer can edit and read, whereas a reader can view and can only view. At the same time, you can, something like this, for instance, is a way to do a super user in any platform. And this schema has things like the plus button and also the arrow to traverse. So here you can actually say something like an admin has access to everything in a platform who has a relation super admin. So you can actually traverse using the arrow. You can also do things like unions with a plus sign. So it gives you infinite flexibility to really model your use case in a schema. Once you have a schema, you can create, read, update, and delete relations between these objects. So for instance, going back to our good old example, say you have a document, you have a reader, Fred, and a writer, Jill. You can write these relationships into your authorization database. So you would just say something like document, some document. Jill is a user who is now a writer. The same thing if you want to do for Fred, you would replace writer with reader and user with Fred. So this way, you are writing relationships into SpiceDB. And lastly, you want to check for permissions. Right? Does Jill have access to this document, and so on. With SpiceDB, you can do it in 2-3 different ways. And here's where you pay attention, because I'll come back to it a little later. You can, of course, check permission. Again, does Niv have reader permissions on some document? You can do that. You can also look up subjects. So tell me what resources does some document, or rather, who has access to some document, right? So in this case, who has reader permissions on some document would be Fred, Kim, Jill, and Niv. Who has writer permissions on some document would be just Jill and Niv. So it's a reverse lookup. And you can also look up resources that individual users have access to. So in this case, it would traverse backwards. So Fred has reader access to some document. And of course, there would be many other documents potentially connected in this graph. So these are the 3 APIs, and we'll be using one of them in our demo, so keep that in mind. So we have this new way to do authorization, and we've seen that it works at the scale of Google, and we know that it shines where you need low latency, when your permissions requirements change often, when you need consistency of data, and also you want auditable logs as to when this permission changed, who was able to access what. And guess what? In AI, like our previous speaker said, these are the requirements we need for fine-grained access control. So it turns out a Reback or a Zanzibar-like system is ideal for authorization when it comes to AI. Now, unless you've been living in a rock, we've all been using or trying out AI. And I like to think that 2024, last year, was the year that we all experimented and built proof of concepts with AI tools, with RAG pipelines, LLMs, agents, and so on. And essentially, this year, we've been deploying AI to production. I think many of us here have. I know I have as well. And we've seen with retrieval-augmented generation as a popular way for people to use AI in production. Now, retrieval-augmented generation, or RAG, is an architectural approach where you augment a LLM with some domain-specific data. So say in your company, you have a large corpus of documents and data, and that is only people in your company know it. It's very specific domain. Now, it's a lot of effort to train an LLM just on that data. And you don't want to ask a general-purpose LLM the same information because it can hallucinate. So you essentially augment an LLM with information from this. So it's an architectural approach. In today's demo, I'm combining a RAG with an agent. So basically an agent that goes into a RAG pipeline and retrieves information based on whether it has permissions or not. The one thing, though, is if you've ever checked in any code in an enterprise, you would have heard of this industry body called OWASP. Anyone's heard of OWASP? Yeah, I see people nodding. It stands for Open Worldwide Application Security Project. And they detail things like security risks for web apps. They came up with the list last year for about security risks for LLMs. And 3 of them, disclosing sensitive information, giving an AI agent excessive agency, it can access things it's not supposed to, and also vector and embedding weaknesses, where you can add malicious code into a vector database to get something that you want. It highlighted these 3 as in the top 10. And 3 of these can be solved with proper authorization. So it's important in day 2 ops of AI to think about this. So let's look at how an agentic RAG pipeline would typically look. There are 2 phases. The first phase is ingestion. So you have a corpus of data, this knowledge base, and you send it through a preprocessor to clean it up, and so on. And then those documents are sent into an embedding model. Essentially, an embedding is a way to convert words or anything else into numbers, because that's what a computer understands. And once it's in an embedding model, you send that embedding into a vector database. The key here is to do it with metadata, to show that this piece of information came from this particular document. Right? Keep that in mind. The second phase is the actual retrieval. Again, a user asks a query to an agent. The query goes through the embedding model, and the embedded query is then sent to the vector database, which looks up information, goes to the LLM, and the user gets a response. You'll see here that there's one thing missing, which actually is the security aspect. There is no check anywhere of what this user or this agent has access to. And that's the demo I will be showing you. So how do you prevent AI agents from accessing unauthorized data? Well, there are 2 basic steps to actually do this. And the first one is called a post-filtration approach, where you do a filtration after the vector database. Again, this is similar to our previous slide. User asks an agent a query. The query goes to the embedding model. We get the numbers. That embedded query goes to your vector database, and you get a bunch of relevant embeddings. And now, post this filtration, you can actually use a Zanzibar-like system to check for permissions. So once you've said, OK, these are all the embeddings that are relevant, you can actually see if the user has permissions for each of them and make this check. And only for the ones that it has permissions to, you can send it to an LLM, and you can get a response back. So this is called a post-filtration approach. This approach is good when the hit rate here is very high. So say the user has access to a lot of documents. You can make check permission requests very quickly and then get a response back. There's another approach called the pre-filter authorization approach, where you do it before going into the vector database. So user asks the agent, you have a query and an embedded query back. And now, instead of doing a permission, you do a lookup request saying, give me all the resources this user has access to. So it'll give you a bunch of documents, and that's the response you get. And those documents are then sent to the vector database, which then goes to the LLM, and you get a response back. Again, it depends on your use case, but when you have a low positive hit rate, this is better. Say you have 1 million documents, and maybe the user can access 10. You can do a lookup resources, get those 10 documents, and then send it to the LLM. So it really depends on your use case on when to choose pre or post filtering. In today's demo, I'm going to show you how to do pre-filtering. And for the demo, we will use Pinecone as our vector database. We will use OpenAI as our LLM. And we will use SpiceDB as our Zanzibar-like system to check for permissions. And we will be using LangChain as well to construct the embedding. So the demo is fairly easy. You can access it here on GitHub in a self-guided workshop format, so you can actually do it, if you want to follow along. If you want to take a photo, now is probably a good time. And I'm going to switch to a Jupyter Notebook and show you the demo. Okay. Making a small prayer to the demo gods that the conference Wi-Fi holds up. You never know how that goes. Okay. Hopefully you can see it at the back there, folks. Good? All right. One is I have an instance of SpiceDB running here. So I'm running SpiceDB locally. You will see the checks happen right here. First, I'm going to create a SpiceDB client. This is straightforward coding. I'm going to create a Pinecone client. I've already created this before because it takes like a couple of seconds, and I'm creating an OpenAI client as well. You will see my Pinecone database here. It's called agents. So now comes the fun part. So first thing I said is you always want to define a schema that looks at your use case. So in this case, this is our schema. We define the things, right? A user and an object. So we define an agent and a document. And we define the relationship between the two. An agent is a reader, and anyone who can read has the read permissions. Very straightforward, right? We're not making it's just a simple demo. So an agent who can read a certain document, or the agent can't read the document. So I'm going to write this schema to SpiceDB. And you will see here in my terminal at 353, there was a write schema. So it's speaking to the SpiceDB instance that's running there. Now, this comes the interesting part. We are going to add relationships between documents and agents. And this is what's called fine-grained access control, where each document, it's very fine-grained, each document has a permission to an agent. You're not just saying an agent can access all documents. So say we have a sales agent. It can access document 1 and 2, remember that. And the HR agent can access document 2. Essentially, what we're seeing here is the way to create a relationship in SpiceDB. You're saying this object ID and document, object ID and agent, and you're creating a relation between two resources. So I'm just going to run that. And you will see here in SpiceDB, these relationships are written. Yeah? So all this is happening live. Now, we have our documents itself. We're going to create the vector embeddings and push that into Pinecone, which I've already done. But you can see here, the sales bot can access document 1 and 2, which are these two, right? Again, this is just for illustrative purposes. And the HR bot can access this one, which says something about employee handbook. Right? Again, illustrative purposes. These have been upserted into Pinecone already. If you see it here, you will see these are the vector embeddings in the database. Now, once that's done, I've created this function to get all the documents that this user is authorized to view. Essentially, this step. This lookup request, that's what I am doing here right now. So this, again, is the way to do a lookup request in SpiceDB. And of course, I have a query here with a secure pre-check, which tells me which model to use when I'm speaking to the LLM. In this function here, that's exactly what I'm doing. I'm listing the allowed IDs that I get when I call that previous method. And then I do a match to check if it's authorized or not. If it's unauthorized, I say you're not authorized to view this. If it is authorized, I do some basic prompt engineering. And I say, hey, this is the context I need. You can see this results.output. Answer only based on that. And then I'm creating my OpenAI model and calling it. So let's do that now. So we're going to ask this question saying, what is the content of document 2? And I'm going to ask the sales agent. Right now, sales agent has access to document 2, so it should be able to get, so its allowed IDs are document 1 and 2. And the content of this is about customer use cases, et cetera, right? So it's authorized to get that document. So it gets information from that document from the RAG pipeline. Now, say something changes. We're like, hey, the sales team can't access these customer use cases. Remove them. All you have to do is write a new relationship. In this case, we are deleting the relationship between document 2 and the sales agent. Again, this is fine-grained access control. Right? So I'm going to delete that. You can see that write relationships is deleted. And now we will ask that question again. And if it's worked, it should say, you are not authorized to view this document. Because it doesn't have permission in that RAG pipeline to view that document. So this essentially is how it would work. And now this was, of course, a demo. It was very simplified. But I can tell you for a fact that large AI companies are using this model in production right now. So when, say, an enterprise uses an LLM, they're using Zanzibar-like tools to make sure that enterprises are safe with their data. And essentially, this AI agentic authorization model, it gives you functionality control. So when you add new functionality to your app, you can control who has access to what the agent can access, et cetera. I just showed you this bit about fine-grained permissions management as well. But you could also add something called autonomy oversight, where you're saying, hey, some things are critical, so I will want a human in the loop to authorize it. So after the bot or the agent has accessed something, or you need a human approval to approve the actions. And there are some second-order effects to this as well. One is you get an audit log of all of your actions. So anytime a permissions changes, you'll get an audit log. Anytime an agent accesses something, you get an audit log. And you end up optimizing your RAG pipelines. Instead of it looking at 1 million documents, you're doing some sort of filtration to get only what the user has access to. So you're improving the efficiency of your RAG pipelines. The thing is, there are lots of known unknowns now. AI agents are so new. We don't know what the developer experience is going to standardize like a couple of years down the line. We don't know who the user, or rather who the agent will authorize against. Is it the user itself? Are you going to attenuate this session where you get like a subtoken to allow the agent to access for some time and then it expires? MCP, or Model Context Protocol, is new. So where does that come into this? We don't know. And the authentication authorization specs are still not there because this is so new. There's been an attempt to do that for MCP, but it's, again, very, very basic right now. It's not fine-grained enough. So we don't know what these will look like, but I think it will be very interesting to see how this actually evolves with time. Anyway, I'm almost out of time. One last thing. If you want next steps, I'd say read the paper. It's actually very interesting. This demo is on GitHub, and you can check out SpiceDB. There are also some other resources on YouTube and on Discord if you're interested. Anyway, I hope you learned something new. Enjoy the rest of the conference, and thank you for having me. Any questions? Yes?
What are the use cases where it's better to use the pre-filter and post-filter authentication? What are specific use case advantages over each other?
Yeah, so the question was, when do you use pre-filter versus post-filter? My favorite answer in all of tech is it depends. It really depends on your use case. Right? One thing I mentioned is if you have a high positive hit rate, you probably want to use post-filter authorization, right? Like this. Here you don't want to use, if you have low positive hit rate, you don't want to use this because say you have 1 million documents and the user can access just 10, you're actually going to be doing check permission requests for that many, right? For that, you would rather use a pre-filter approach. The one thing you need to know is a lookup request is a lot more expensive than a check permission request because a lookup request goes through this entire graph. So a lookup request goes through this entire graph and has to scroll all the way down. So imagine if you have 1 million documents, it's an expensive operation, whereas a check permission is straight almost. So it's a faster operation, right? So really depending on your use case, you want to check which one works best. We have seen clients basically test for both, look at performance and latency, and just choose the two. Any other questions? Yes, sir.
What if you give it a query like summarize all the documents you know about, for your example? Would it just omit what the user needs to see?
Yeah, pretty much, right? So because of how we have done, let's assume we're doing a post-filter approach. It would, the question was, what if you have something like summarize all the documents in that pipeline? So in that case, yes. Every check is made for only the documents that the user has access to. And then there would be a check there. And then the LLM would actually look at all of those documents and do a summary of the entire thing combined. Yeah. Any other questions? I'll cede my own question because I get asked this often. So people ask me, do I have to use a Zanzibar-like system or an authorization tool here instead of just, say, any filtration or search tool? My answer to that is it's about using the right tool for the right job. Search and filtration tools are meant for searching and filtration, so they do a great job at that. They do a great job at caching. But when the permission for a document changes very quickly, that might not be reflected in a search tool, which is why you need something like an authorization tool. Now, if your requirement is your permissions don't change at all, then by all means, you could filter using something like a search tool. But that would assume very static data with very static permissions, which typically is not the case in a RAG pipeline. Right? So I think that's one question I actually get asked pretty often. Any more questions? All right, I'm around if you have any other questions I want to chat. There are a few stickers there as well if you want to grab some. Thanks for having me. Enjoy the rest of the conference.